Welcome everyone to Mark Voids a Warranty. I'm Mark, and this is how I void warranties. Oh yeah, nice little drill and hammer. If you join me next week, we had an absolute catastrophe with tearing apart that device, and it was just built far too well, especially for my purposes. Now, I hit that thing for a good 30 to 40 minutes, and it did not break. It was built well. And I used a bigger hammer, a sledgehammer. This is a drilling hammer. And I hit it so hard that I actually vibrated the power plug out of this mixer that I'm using to display these things. It was a lot of fun. If you missed it, go back and watch. You're going to like it. All right, so today we have an Asus Netbook that is several years old. Looks like it ran Windows 8 as its claim to fame. So we're going to take a look inside, see what's there, see what's interesting. We're going to void a warranty. Yeah. Please, as we're going along, ask questions if you have them. I'd be happy to answer them. Okay. So here we go. On the back side, we've got several case screws that are easy to identify. So the first thing we're going to do is pop those. I see my friend Brian has joined us. Hello, Brian. Oh, you know what would make life more interesting? Let me put that on, and then I don't have to be so loud. How about that? Oh, not the right. Oh, that's a torque bit. Ha ha. Wrong one. So after last week's debacle, I did invest in a hot plate in case we ever come upon a glue situation again. We should be able to solve it with a little more grace and a little less broken glass. Although I don't have much experience using that sort of thing, so there's probably a good chance there's still going to be a lot of broken glass. Who knows? Oftentimes when you're taking these things apart, there are screws on the bottom and then sometimes screws hiding under the keyboard that hold laptops together. It just depends on the manufacturer and the design. And the age. Did I get in that hole? These things are inserted at a slight angle, which is interesting. Don't know what that's about. And then we'll see the way that they know that you opened it is they'll hide a screw underneath one of these stickers sometimes, and I can feel something under there, but I don't know if those are just spots from the injection mold or not. I don't know. Okay, well, we'll not worry about that. Another favorite place to hide stuff is underneath feet. I don't know that I'm going to find any here since there are case screws so nearby. Oh, there are. So these things gots to go, yo. That's me speaking hip. It gives me street cred. All right. Yep, thank you for that, Brian. Sorry about the audio. I forgot initially, but we've got it now. Okay, so there's everything that is readily viewable on the bottom side. Let's take a look at the top. It's possible that top breaks free. Okay, we're loose. We've got some ZIF connectors, zero insertion force, on some flat flexible cables. So those are gone. So we've got our keyboard and trackpad. Looks like there's some circuitry there we might want to take a look at. And a few LEDs. So we'll set that aside for now and keep digging. Looks like we've got a couple cool PCBs to look at. And we're already in, and we're only 4 minutes in. I tell ya. by the way, as we go through this, if you enjoy Mark Voids a Warranty, please remember to like, subscribe, and hit the bell so you're notified every time I take something apart. As soon as we get to 500, that's my goal, 500 viewers or subscribers, I'm going to take apart a production camera lens. I'm really looking forward to that. And I'm at about 448. So if you know anybody to recommend this channel to, you think they might like it, please do. Okay, trying to get the fan out here. I'm going to change tips to a, probably just a flathead, if I can. Ah, come on, there we go. So I'm just going to put a little bit of pressure on each side and see if I can pop it without breaking it. There we go. So just a little fan there. Air goes in the top, and then this thing spins around, and as the air goes in, inertia flings it out here, where it passes in front of this slightly dirty heat sink, and the heat sink's connected to a heat pipe, which is way cool. So we'll take a look at that in a minute. Then we've got a speaker. These just look like JST connectors. I'm not entirely sure of the pitch. And is it glued in? I guess it's glued in. So I'll have to work on that in a minute. Another ZIF. Just want to be gentle with it. These things are very fragile. They do not like opening back up after you close them. If you're not careful, you'll rip that little cam connector right off. So one of the things I never understood about netbooks and notebooks is why the designers put the batteries right there underneath the screen. It would seem that if you want to counterbalance this thing to keep it from moving, that you'd bring that way out front and use the mass of the battery as a counterweight. But what do I know? So right now I'm just going for visible screws around the hard drive. See if we can get that out of the way. Little piece of foam, little piece of drive. So what was this bad boy? 500 gigabyte. That's not too shabby for as old as this thing was. Half a terabyte's nothing to sneeze about, or nothing to sneeze at. Come on, little guy. What are you caught on? It's caught underneath that. Okay. There we go. So over in this side, we've got a network card. That's a cute little connector version there. Wireless LAN gives you the MAC ID. Oh, and then there's all of the information on the back side. Maybe we'll take a look at that too. We're making pretty good time. All right, so we've got the main logic board on the left. Over on the right, we've got an auxiliary board that does a lot of the peripherals, that sort of thing. You know, we've got USB, a network. I assume that was the audio. It looks like audio, SD card reader. And then, of course, we just took out the Wi-Fi. Bet you there's going to be one right here. Yep. Comes some status LEDs that shine through heat pipes that were on the keyboard. All right, if you see that I'm missing any screws, be sure to shout them out. But one of the cool things on this design was that the PCB designer silk screened in the case screws. So you've got little arrows next to each and every one of them. A little attention to detail that I like. Okay, is that a piece of plastic or rubber stuck there? There we go. I feel like I've gotten all of them. Nope, I missed one right there. See, you guys can actually sometimes see these a little better than I can because you've got the overhead view and I'm oblique. I'm at an angle. All right. So there is our network connector, the magnetics for it, USB, some sort of microcontroller doohickey, SD card, and another ZIF connector. Pop that. We're making great time. We are 11 minutes in, and we've got this thing almost in pieces. Batteries out. By the way, if you ever do void a warranty, don't go hitting lithium ions with a hammer. Bad things happen. And if you do hit one with a hammer, do it at somebody else's house. They always say don't try this at home. But nobody ever says don't try this at your friend's home. That's the safest place to do stupid stuff. Another one here. Okay. I've got a high density connector there. And here is our logic board. We've got a heat pipe, and I'll talk about these in a little bit. I love heat pipes. Connected to the main microprocessor. Transfers, it would evaporate here, condense here, and then blow out through the fan. So I might actually be able to do something with that in reuse it for a project. Let's see. Well, I'll continue to take apart and then we'll see from there. All right, so we've freed up everything in here except for the speakers, which, I mean, I don't know if we want to do anything with that anyway. So now it's time to move on to the display. Boom, boom, boom. If we do get to use that heating pad, that hot plate, the display would be the spot, but we'll see as we get in here. Okay, so I'm just taking the screws out of the friction hinge that connect the base to the display. So all that's left here are speakers. So I don't know if we'll do anything with that. We'll see. So next up, I'm going to get a couple of these pry doohickeys and see if I can't get underneath this. I might need a blade. That looks pretty tight. Let's see. I'm a fan of Asus for little things like that. They're my go-to for motherboards, not so much for laptops anymore. I had trouble with one. Once I found MSI, I haven't looked back. All right. So we've got some product recommendations there from our friend Brian. Uh-oh. I think I've answered my own question. I think with trying to get under that, I discovered that is a piece of glass and not a piece of plastic. So let's see if we get to it from the edges here. If not, we're going to have to hot plate it. I was about to say I don't take things apart for a living, But then it occurred to me, I'm getting paid for this. So I do take things apart for a living. It's a tough job. Somebody's got to do it. Come on. Okay. So the back side, we've just got more friction hinges. And that was just press-clicked together. And Brian's telling me the tool I'm playing with is called a spudger. All right. Okay, what's next? More screws. So we've got a few wires that are dangling down in there. One of them is the display. It's going to have, multiple twisted pair connectors that go to this guy, and that actually is going to run the display. And some of these others, like these two right here, are for Wi-Fi antenna. So that Wi-Fi module has a little bitty coax cable that runs up and over to one of two antennas. Come on, there we go. So these are just little RF antennas that have been taped in position with, looks like it was just soldered right on there. So nothing big there. We keep removing things, and we are doing pretty good. Making excellent time on this teardown. All right, got some tape to cut. And that display should be free at the top and just taped at the bottom. Let's see. Missed that little piece of tape there on that second antenna. Come on, little guy. Okay. We're free. As free as the wind blows. So here is our display. We'll take a look at that a little bit more in a minute. And then here is our touchscreen. So I don't know if we're going to be able to see at all how that works. We'll have to look a little closer here. Let me get that second antenna off. Whoops. Come on. There we go. So I can kind of make out the, I don't think I'm going to be able to show it on camera, so I don't think I'm going to get into that. But I can kind of make out some of the sensor patterns in this display. I'm trying to think if there's any way I could illustrate that. Maybe a laser would do it. Whoop, just cracked it. Haha. That's what I get for playing with it. Yes, Brian, it is a good thing I'm not paid to put them back together in working order. We call it Mark voids a warranty, not Mark fixes things. Even as a kid, I was never great about that. Once I had the stuff apart, that was the extent of my interest. Many a typewriter, adding machine, computers, VCRs, anything I could get my hands on. All right, so this little guy is our camera board. I have freed it. And then let's see if I can further. It is possible sometimes to go get new driver boards for these things, but sometimes it's more trouble than it's worth. You can go get a display and a driver board and call it a day. But it is doable. It just takes time. All right. Again, we're making very good progress. I'm going to see if we can't see what's inside an LCD. This might be one of our best examples yet. If we can get it open safely. But Brian, that crack in the screen, man, that's nothing to worry about. A little super glue, some ramen, have that fixed right up. Looks like we've got some tape to contend with that's holding the circuit board on. Let's see. I might have to grab an X-Acto. Hi, Chester. Hey, let me grab an X-Acto knife. Give me one moment. I think I've got one sitting right here. Maybe I don't. I'm going to go with I don't. Sorry about that. Hi, Chester. Where are you, buddy? Where are you? Come here. Where are you, stinker? Okay, now we'll find him. Okay, back to this. Yes, Chester. You know, we name our pets. Don't even know if they understand what names are. But I think if he had a name for me, it would be the food bringer. And my other cat, Ollie, would think of me as the belly petter, in honor of his favorite thing. Okay. Bye-bye tape. So it looks like this is screwed on to very, very, very small plastic, or not plastic, but very small metal tabs. I'm going to probably have to grab, oh no, the screwdriver is going to catch those. So this is the display driver logic board, and it connected through one, I think it was this connection right here. I'm going to pop that free. This is more than likely the connector for the backlight. And then these guys are not going to come out safely. There we go. All right. Let's keep going. We're making progress. Very little left to take apart. Well, I guess the hard drive. And then we get to start looking at things. That's why everybody's here. Where are you, buddy? Come here. Come here. Cats, I tell you. If anybody ever invents a universal translator that tells us what cats are thinking, I don't think we're going to want to hear it. Okay, what's left here? More tape. Is there a piece of metal? Yeah, there's a piece of metal, so I can't cut through this side. It's got to be this side. If I can scrape it. Oh, this is great for the blade. There we go. Now we're getting somewhere. Okay, metal frame removed. On the bottom of the metal frame, we've got that little flippity flat flexible connector, which actually has some interesting routing. I wonder if I can get that free. It drives usually a fluorescent or an LED tube that lights up the display. In this case, it's an LED. I'm going to see if I can get it out. I don't know that I can. Might need to open this up a little more. Uh-oh. Oh, no, I just clicked. Okay. That definitely had the tone of breaking plastic. What's too scary, Brian? There's a delay between when you type and when I see it. Was I talking about what happens when we can understand cats? Okay, we're making progress here. Not fast progress, but progress. There it is. Come on. No. Oh, it's that part. Okay. It's the stiffener. Got it. All right. So we've got an array of LEDs that all get turned on, and they put light into a piece of plastic on the back here. It's a reflector. Oh, I cracked it. Bummer. Wonder how I did that. So the light hits this piece of plastic. When it does, when it comes in from the edge, let me see if I can demonstrate here. I don't know if this will work. But there's it's far too bright on these screens. But anyways, there's a pattern of little serrations on this. So when the light hits, it reflects out. And one of the things it'll do is bounce off the back of this white shiny thing. Then there's a couple diffusers. And these parts are always cool. That is like the world's craziest diffraction grating. I don't know if you can see the pattern on that, but you hit it at just the right angles, right? Light goes through, light doesn't go through, it bounces all over the place. All right, buddy, come here. Come here, there you go. I tell you, the cats these days. But anyways, these things, if you ever do get to play with them, you get these cool holographic effects. Might be useful for some project. I don't know. So this one has two diffusers, two of those little deflector sheets, and then the LCD. So the job of all of that stuff is to put a nice, consistent white background for your display. And once it does that, then you've got these crystals that will twist between two polarized filters. So all of these little lines here are part of an array. Anyhow, so that's basically what's behind an LCD. You've got two polarizing filters. Between it, you've got a crystal that responds to electricity. You energize that crystal, and the LCD will, the little color it'll rotate and it'll give you different colors. That's basically it. All right. Microscope time. What shall we start with? I think I want to start with the control board here. That is some tiny, tiny routing. Come to me. Whoop. There we go. I have made a mess, I tell you. We could call this Mark Makes a Mess, but that's another series. Let's get this thing prepped and on screen, huh? All right, so here's the first thing that I saw that I thought was kind of interesting, the way that they ran these wires. These copper traces. They had to do an inversion of a few of these, which is always a pain in the butt. So instead of running on a single layer, they did the crossover at the bend. And you can see where they've tied with multiple vias these copper pores where they could. So I thought that was kind of interesting. So then back on our back side here, you can see where they finished and then took a right angle turn, did a little bit of tomfoolery. That discoloration that you see is ink, some sort of barcode marking, I'm not really sure. And then they just go through and they tag each individual LED. Looks like they've got some copper slivers in there. I don't know if I would have left those myself. So these floating traces that don't connect to anything, like this one right here, I don't know if I would have left that in. But it's possible that the fabricator requested them. I can't imagine that they would, but it could just be an oversight. Who knows? This is a little stiffer than you would expect Kapton or polyimide to be. So they've probably got a layer, I don't know if we're going to be able to see it or not, but they've probably got a layer stiffener in here. I don't know if I can zoom in sufficiently. We'll find out. There we get to see an angular or angled view into the LEDs. They're side blast LEDs. I can kind of make out a couple of these layers, but I'm not going to be able to separate the adhesive from, I'm not going to be able to pull that apart for you. Sorry, viewing audience. Is it really the thought that counts, or do you want results? I don't know. Okay, next up we've got the board that controls the LCD, and I need to back out. All right. So we've got a little diamond-shaped fiducial. This is interesting right here. I don't know what's going on there. You would expect with continuous traces for the connection, but I don't know why they split that one. They had to do some breakouts so you can see some different with some micro vias versus normal vias. So the micro vias they went back and filled. Let me get a pointer here. But see how there's a difference between here and here? So these are bigger vias, but they simply couldn't put bigger vias here, so then they went the micro via route. Couple unpopulated resistors. What appear to be the makings of some differential pairs. Why we have, oh, for test points on the back side. I was wondering, typically you try not to add additional vias to diff pairs if you can help it, but the reason they did that is back on the back side, you've got test points. We can talk about that in just a second. So as we keep moving around, combination of micro vias, regular vias. Why these are micro vias, I don't know. It could be they just go down a single layer. This is a multi-layer board. That could be the difference in these for this case. So they're doing blind vias. And micro vias usually only go down to the next layer anyway. So a lot of missing components, a lot of components that are non-populated for whatever reason. So as we move over, we've got something that looks a whole lot like an inductor, so we're probably into some power regulation aspects of the board of unpopulated components. And we keep cruising apart or across. Man, this thing must have been a nightmare to route. But you would do it in blocks, right? You would deal with the power block, you would deal with the signal. But I can only imagine how difficult this thing was. A lot of mechanical constraints, obviously. Your board can only be so wide. I don't know if we can see. Now we can't really see how many layers are there. Certainly at least 4. And then on the back side, we've got an absolute plethora of test points. Test points are all on one side. That keeps test costs down, but I'm sure this is also program points. So they need to make sure that everything worked well. So you would put this on a bed of nails fixture. AUO. Here we can see a BGA, and they went ahead and silked in the pin. So there's going to be a ton of stuff coming out of this, and you can see all of these traces. Again, man, must have just been not a whole lot of fun to route. Several serial clock and serial datas, some tracking code, and here we are on the far side. So that is the LCD display one. Interesting. Interesting, interesting. All right. What do we have up next? I buried it underneath my display carnage. All right, next up, let's take a moment and do a little low-hanging fruit. So this is our, just our connector board. So let's take a look at that under the microscope, see if there's anything interesting. I bet you there is. So this is something I see every so often, and I always wonder what the true purpose is. I have an idea, but I could be wrong. So let me share that with you. I think what they've done with this copper is they've drilled a ton of vias all around it. So each one of these is a via. And then they went ahead and I bet you they meant to fill all of those. They went ahead and filled them with solder. And I think what they're trying to do is rivet the copper on this layer to the copper on the bottom side. I think they're trying to give a spot where you can make connections to the case. and also strengthen the copper in that region. That is, of course, a guess. I could be wrong. I don't really know. But I think they're trying to strengthen that all around. Copper has an adhesion force that's similar to, run-of-the-mill tape. If you have a good packing tape, it's maybe 10 plies or whatever the units are. I could be remembering wrong. And copper's right in that range too. So here we've got either a power or reset button running over. Some interesting things you see where they have connected things. There's a great deal of space in here. Usually you do that if you've got high voltage nets. I don't know that they do. I don't know that they don't. But that's usually the reason that you see such large amounts of space. So what I think they have here is that this is a copper that is connected to the ground net, this copper pore. And I think that this is too. However, they've connected it through a resistor. What they're trying to do is keep noise that's generated by the high-speed switching signal lines here. This is the RJ45 jack. I think they're trying to keep that at bay. So you've got some 0-ohm jumpers that they can intercept and test the high-speed digital lines. One set of these diff traces is transmit and the other is receive on the RJ45. I used to know which one's which. I don't know anymore. I don't know that it matters. But I really like that they doubled up those vias. Oh, that's good. Let's look on the back side of that. So on the back side of this, we've got what are called the magnetics. These are little pulse transformers. So they don't allow voltage. They don't allow current to go straight from these pins into the rest of your project. They allow the signals to create a magnetic pulse, and then that goes through a transformer, that goes through another transformer, and then that goes into your circuit. So these things are kind of galvanically isolated through this little pulse transformer here. And usually what you want to do around these are have copper exclusions. And again, you're just trying to keep the noise from getting to the rest of your design. Copper exclusion, they also did a kind of a via phase stitching those together, but whatever. I'm sure it's fine. All right, on the back side, we can see evidence of another via fence connecting to ground. And going to keep moving around. So this is the IC that I pointed out a long time ago. Where is it? There we go. But I'm sure we could figure that out if we needed to. Some interesting things, some break trace jumpers. So if you wanted to reconfigure this or do something to it, you can basically take a sharp knife and cut the copper in between those two things. And that reconfigures it. Not that I am using a knife, I am just hitting it with a pointer stick. And then if you want to reconnect them, you can solder them. But look how oxidized those traces are, man. You'd have to really clean those things up before you tried to solder them. The solder just wouldn't stick. Exclusions in these portions of the board. This is underneath the SD card. So they're probably trying to do the same thing, trying to keep noise from entering the return path and creating a ground loop. That's interesting. I don't know what this thing's doing. It's like that break trace thing, except I don't know. You can see differential pairs run together. Differential pairs don't really couple all that well to one another, but the nice thing about running them together is that they will both hopefully experience the same noise level, and that common mode noise can be rejected. Here you'll see, where is it? My field of view in the camera is much greater than, I'm sorry, in the microscope is much greater than yours, so sometimes I forget that I'm not aligned. All right, so here's something that I like to see. So when you're doing power connections, you use multiple vias to connect the layers. That gives you low impedance paths for the current to take. You don't care which one it takes, you just want it to take one. And then have at it, boys. All right, that is almost all the interesting things. There is this, something you don't see too often, a dual LED in a single package. Let's see if we can zoom in on that. Sorry for the shakiness there. So that's kind of interesting. You've got the LED as, now I can't find my pointer. Yeah, Mr. Pointer, pointer, pointer. Oh man, this thing is zoomed in. Okay, there we go. So the actual light emitting part is that little square and then a bond wire goes from that LED over to a pad. I don't know if that's anode or cathode, but anyways, interesting. All right. Moving on, we're going to back off for a moment and remove that heat pipe and talk about it. By the way, if any of the viewers out there have questions or comments, please feel free to leave them. I do look up every now and again when my head's not buried in the microscope. I want a tiny screwdriver. I should have put a little greater spacing between these when I made it. Okay. Nope. All right, here's 1, 2. So copper has a thermal conductivity of, it's in the neighborhood of 400 watts per meter Kelvin. The only thing better than that, only metal better than that, is silver. And I forget exactly what they are. They're different by like 30 watts per meter Kelvin. To put that in some sort of perspective, standard FR4 has a thermal conductivity of about 0.4 watts per meter Kelvin. So the PCB material is 2 orders of magnitude less than the it's 2 orders of magnitude less than the copper, just regular copper. Now, copper heat pipes play in a different world. Copper heat pipes have a thermal conductivity up to like 40,000 watts per meter Kelvin. It's not even in the same wheelhouse as standard copper. All right, it's moving now. So the way that these things work, let's zoom out a little. So the way these things work, it's a condenser on one side and an evaporator on the other. You've got a hollow space in the middle filled with sintered metal. I don't know if it's copper or not, but it provides a path for a liquid to heat up, evaporate. It'll travel over here where it'll condense. Then it'll go back, evaporate, condense, evaporate, condense. It's a completely closed passive system. There's no active transport other than heat tends to move the molecules from high temperature to low temperature. Clever, clever, clever. And then this little fin system is amplified by the fan. Forget which way it went. Maybe like this. So the fan just takes and shoves air through there, and it can remove a ton of heat, an absolute ton of heat. I don't know. I'm not a thermal engineer, but if I had to guess, we're probably looking at like 2,000 watts per meter Kelvin. It's a lot of heat that it can move. So love those things. All right. Now, to continue our teardown. So that was covering a processor that appears to be covered in Kapton tape. So they knew that the thermal paste was going to kind of squeeze out when they installed it. So I want to get rid of that there. So they tried to protect the rest of the IC with Kapton. And it looks like it's bonded right onto there. I don't think I'm going to get that off. What about the back side here? Nope, not coming off either. Okay, so let's take a peek, shall we? So here we are looking at one of the main ICs. I have no idea what this one does. Based on its position on the board, it's not giving me any hints. But you can see that this thing is a board on a board, right? All of these, you can kind of see through the material, and you can see layers of copper with vias all over the place. And you can see right in here a bunch of traces that are going around. They give them extra length wanders so that when the signals leave this, they all arrive wherever they're going to go at the same time. The distance doesn't matter. The impedance, well, you kind of try to keep that the same. But what they're trying to do is get all these things to arrive at the pads at the same time. I don't know if that's a video processor or what. But you can see some things as we look around the board, some random vias. They did a combination of copper pour and copper exclusions, and all of that is in an attempt to mitigate noise and make sure that this thing stays EMC compliant. Some of these break trace spaces, some unpopulated parts of something. I don't know what that was. It looks like it's a transistor. Maybe a SOT23. I don't know. Sometimes, so this is a VGA connector right here. And sometimes you'll see engineers that, add these little meanders, and they're just not necessary. The signal timing, the time to travel that short distance is got to be in the picoseconds or femtoseconds. It's going to be small. Is that really going to adjust your timing that much? I don't know. I would think not. We've got VGA next. That's this connector. I'm sorry, is that HDMI? What am I looking at? Yeah, it's HDMI. Sorry. So a bunch more of those make-break things so they can pick up pads and do testing or reconfigure depending on, what it is that they're doing. Looks like those might be testing. USB 3. So we've got some diff pairs, and then, they run down here and then go under, it looks like, and then maybe make it into here. That IC that we were looking at earlier. So that IC might be a VGA driver, HDMI driver. I mean, it would make sense. All right, I've rotated the board so we can get a better look. Looks like we've got memory. So I can give you a better focus there. How's that, TV Land? How's that? Bunch of memory, a bunch of meanders here. So they were really worried about the signals either coming in there or going out of there. And you do see that with memory. There's going to be a lot of traces that have to run. Memory is usually a parallel interface. Well, that's not always true. You can have SerDes as well. But if you have multiple data lines coming out, you want them to all reach at the same time when the clock hits. And the way that you do that is with these meanders. It takes extra time for the signal to make it. All right, continuing to look around for interesting things. An absolute ton of test pads there. And look at all of that trace routing. I mean, these are all 1 mil traces. These things are tiny, tiny, tiny. Interesting, interesting. All right, let's keep looking. We've got some power sections over here. I can zoom out here. No, I can't. That's zoomed out as much as I can zoom out. 220 microfarad, 6.3 volt, CAN capacitors, electrolytics. What's that debris? There we go. I don't know what this is. Where's my pointer? So it's like we've got a hunk of solder that's joining to copper pores, and it's covered in a small piece of tape, and I have no idea what that is. A battery that keeps the BIOS information stored. ITE, WinBond, a lot of different devices, modems, memory. Elpida, I'm not familiar with, but that's our memory. More of those solder doohickeys. Looks like they're just joining copper pores. I guess they weren't sure if they should or not. And that's their solution. All right. Anything on this side? Just small components. I am so glad I didn't have to assemble this or fabricate that. Look at all those vias. Every single one of those things has to work too, or this board gets thrown in the bin. A lot of fabricators will throw out as many boards as they make, just because there are so many things that can go wrong. Oh, there's something. TVS diode, looks like. Transient voltage suppression. So they've got a route to, I assume that's what TV is. I could be wrong. But they've got a route to offload that energy. I don't think we remembered to look for that on the other board. But man, look at all those vias. You know what this tells me? Routing nightmare. It's the kind of board that'll drive you to drink. I mean, take a week to route. Maybe more. It'd take me more. That's craziness. Absolute craziness. All right. Have we looked at everything there is to look at? Have we seen everything there is to see? We haven't taken apart the hard drive. Oh, we've got the keyboard left. So let's back out on the cameras. Get that out of the way. Well, I tell you, for all the hammering I did last week, I haven't even had a chance to legitimately use it this week. Perhaps the universe is smiling. One interesting thing, I don't know if you can see it on the screen, but I don't know if you remember me taking those screws out at the beginning at an angle. They inserted these at an angle. That's some dedication. You don't see that too often. All right, so here's our keyboard. It looks like it's been melted in place, so that's not coming out. So essentially what they've done is all these little black plastic things are little plastic extrusions that came through, and then you press down on them with a hot knife and they become plastic rivets. Never again to come out. Which, I could be wrong. It seems like you would want a way to replace. I could, of course, be wrong. I don't know. Feel like there's something else there. Like a tape or a sticky something. Oh, a screw. Always missing screws. There's always more. Okay. How do we get that out? Does it just fall out now? So there are, I don't know if you can hear that. So there's some switches hiding in there. It feels like it's still screwed in somehow. But that keyboard is melted in place. If only there was some tool that I could use to brute force this. Haha. Didn't even get to use the hammer. I thought I was going to get to use the hammer. I did not. That would have been a good chance. All right. So now we've got a piece of plastic glued in place. Need to get that out of the way. It's gone. Wow, that's some routing. That actually wouldn't take that long, but it's pretty. Let's take a look. All right, before I do that, let me see if I can get this other plastic off, if it comes off. Purdy. Okay, hatched ground. Night. Look. Microscope on. So, the first thing we have, this is the part where your fingers touch. And we've got an intricately designed pattern. That would take some analysis to understand. But this will change capacitance when your fingers are above it. So we've got one way for these all these copper ports to be connected, and then we've got us that's doing a bunch of figuring out what's connected to what. When two things. Hi, Chester. Yes, Chester is letting me know he needs me to help him with something, probably food. Anyhow, so this IC then is doing all sorts of figuring out of what two things are connected to other two things. And some really interesting, I haven't seen ground pores like this before. And I'm just curious what it is that they're trying to do. Because if they're trying to decrease capacitance, they're not decreasing it by much. If they're trying to prevent eddy currents, I mean, I guess it could give some preferential up and Interesting, interesting. But anyways, this was the routing that I saw a minute ago. And it's all nice straight routes, goes up to the edges and whatnot, but that's a lot of traces to keep track of. It wouldn't take that long to route because, we're not doing a whole lot of crossovers or anything. It's all direct connection. We've got all the test pads on one side, all the programming. And test, you'd have to have the schematics connect to. Wow, cool. So anyways, we'll end with that. Anyhow, that's kind of purty. Anyways, I really do hope you enjoyed your time here on Mark Voids a Warranty. I'm Mark, and I just voided the heck out of this warranty. Don't worry, I could totally put that back together. Just a little super glue, some ramen, maybe a little cornstarch. That computer's good as new. But I really do hope you enjoyed your time here. This one went a little smoother. Please tell your friends to like, subscribe, and share this content. We're at about 448 subscribers right now. We want to get to 500. That's just 52 people. Do you know 52 people? I bet you do. If you can get them out there, get them to sign on. We'll get those numbers up, and I've got a broadcast camera to take apart. Mark Voids a Warranty is sponsored by Advanced Assembly Royal Circuit Solutions, and I really do thank them for giving me the freedom and opportunity to do stuff like this just so we can see what's inside stuff, problems out there, and a lot of them have already been solved. It's, like learn from what's going on with this pattern. It can help you in ways you might not understand right now, and it might be a few years down the road, but I encourage you to take apart your old electronics, see what's in there, recycle them responsibly, and like, share, and subscribe. I'm Mark, and I'll see you next time on Mark Voids a Warranty.